This is Mr. V. Welcome to this video series on linear programming. This video is going to be on finding the optimum solution or best solution to a problem. So in a previous problem, we had this situation where Gianna makes sofas, a basic sofa and a high quality sofa, and we worked through that problem to eventually draw the feasible region for that problem. Now today we're going to extend this problem by trying to find the best solution to the problem we've got. So here's the updated question. Gianna makes two kinds of handmade sofas. The basic type needs 5 hours to assemble and 2 hours to finish, and we've already used that information. The high quality type needs 3 hours to assemble and 4 hours to finish, which we also already used, and she employs 3 cabinet makers for assembly and 2 upholsterers for finishing. Each works up to 40 hours on casual rates. So that's all the information we have last time that we used to graph this region. And I've copied that information down to the bottom here. The new information we've got is she makes a profit of $300 on each basic sofa and $400 on each high quality sofa. It's the new information. So our variables, parameters and constraints are mostly unchanged, except we now have this third category, which is profit. And we only have parameters for this. We have not been given a constraint. We only know that we make $300 profit per basic sofa and $400 profit per high quality sofa. It's our job to figure out what combination of basic and high quality sofas gives us the most profit. So the objective function is actually rather simple. The profit equals 300 times the basic sofas plus 400 times the high quality sofas. And this is profit, so we want to maximize this function. So we want the profit to be as large as possible. So in a normal question, you would figure out the variables, parameters, and then figure out the inequalities and graph them, but we've already done that in a previous example, and we're just going to continue on from the point where we finished with this graph. Okay, now the best possible solution is always going to be one of the corners of our possible solutions region. So in this example, we have the possible solutions in this shape. So the maximum, the point of maximum profit, the optimum solution, is going to be one of the 4 corners that we have. We'll name them with Roman numerals: 1, 2, 3, and 4. Now that we've identified the potential optimum solutions, we want to simply put these values for number of high quality and number of basic sofas into our profit equation and see which one is the biggest. So for I, the profit at I, H is 0 and B is 0. So our profit's going to be simply 0. You can't earn any money if you don't sell anything. The second point lies here, right on the h-axis, and profit is going to equal 300 times B, and here on the h-axis B is equal to 0. So it's going to be 300 times 0 plus 400 times, and we've got H, the high quality couches, which we know is 12 at this point. Sorry, not 12, 20. 400 times 20 is $8,000. At point 3, we have to do a little bit of looking around, because that's not right on a point. So we're going to pick the closest point to that vertex, which looks to be this point, which has a value of 10, 12, 14, 16, 18 basic couches. So B is 18. And halfway here, we've got H equals 11. That seems to be the best. Nope, that won't actually quite work. We need to work with this point. H is 10. So at number 3, our profit is going to equal 300 times B, which is 18, plus 400 times H, which is 10. I'm going to grab my calculator. 300 times 18 plus 400 times 10 equals $9,400. Last point right here on the B axis. So we know H is 0 and B is 20, 22, 24. So the profit is going to equal 300 times B, which is 24, plus 400 times 0. 300 times 24 is 7,200. Now we want this profit to be maximized, so we're going to look for the largest value, and we can see that that equates to point number 3. So the optimum solution, the best solution, is to buy 18 basic couches, 10 high quality couches, which corresponds to a profit of $9,400. And that is how we determine the optimum solution, the best solution to a problem.